Today I am going to discuss about Science for Class 9 chapter. Science for Class 9 chapter is also 9 topics. Newton's second law of motion. Newton's second law of motion. Now, in that discussion, I will solve some numerical problems also. Now we go to the point. What is Newton's second law? That means state Newton's second law and hence prove that F equal to ma. Now, question is what? State Newton's second law of motion and hence prove that F equal to ma. Now, all of you know that the definition, what is Newton's first law and what is Newton's second law. Laws cannot be changed, so you state or define directly as the same to the both. Now, Newton's second law states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of the motion. Now you see here, we have to prove that F equal to ma. Suppose there is a body of mass m. Its position is at A. There is a body at point A. There is a body of mass at point A. If we apply an unbalanced force, then in t seconds, this body goes to point B. Same body goes to point B. From that position, it goes to point B in t seconds. Now, initial velocity of the body at A is what? U. And final velocity at point B is what? B. There is a body of mass m at a point A. When an unbalanced force F is applied, then in t seconds this body goes to point B. Now let the initial velocity of the point of the body at point A is u, and the final velocity at the point B is what? B. Now, what Newton said? Newton said that the rate of change of momentum. Now we have to know what is momentum. Momentum is nothing but the mass into velocity of a body. Mass into velocity of a body. So we write like as we have to find momentum. Momentum, that means momentum is what? Initial momentum. Initial momentum. Momentum at point A is mu. Because momentum is what? Mass into velocity. Initial momentum at point A is what? Mu. Like this here, final momentum at point B is mv. B is what? mv. Now, according to formula what? Change of momentum. Change of momentum equal to what? Final minus initial. Final minus initial. That means final momentum. We write directly. Final momentum mv minus initial momentum mu. No? That is, if we take common m, then v minus u. Therefore, as the definition for the Newton's second law of motion, rate of change of momentum. Rate means what? Divided by t. Rate of change of momentum divided by t means what? We have to divide it by time. So, rate of change of momentum equal to rate of change of momentum equal to what? M. That means we directly half time we write what? M v minus u by t. That is the rate of change of momentum. Now, according to Newton's second law of motion, the rate of change of momentum of a body is proportional to the applied unbalanced force in the same direction or direction of the motion, in the direction of the motion. This rate of change of momentum proportional to the applied force. So, by the definition of, or applying the definition of, according to the definition, we can write applied unbalanced force proportion m v minus u by t. No? Now, it is the what? According to definition, applied force F proportional this rate of change of momentum. Rate of change of momentum. Now you see here F proportion. It is the what? Proportion. When we banish proportion sign, then we have to put any other constant, any type of constant. So F equal to K M V minus U by T. This bracket put like this. No, because T is the lower one, here is also T is lower one, it is the upper one, it is upper one, K is a constant. You write here, K is a constant. K is a constant. Now, F equal to K M. This value is what? We know A equal to B minus U by T. A equal to V minus U by T. So V minus U by T means what? A. V minus U by T equal to what? A. That means F equal to KMA. F equal to KMA. Now the main point is that now you see we have to banish K by who can by 2. So here applying the definition of unit force. Applying the definition of unit force, that means applying the definition of unit force, we can find the value of K. Now, what is the definition of unit force? What is the definition of unit force? Suppose you see here is F equal to K M A. F equal to what? K M A. Now, applying unit force. Now, what is the unit force? Here, unit force means what? When a force is applied on a body of mass 1 kg and produces 1 meter per second square acceleration, then the applied force is called what? Unit force. Suppose you are given it is a body of 1 kg. It is means unit mass 1 kg, and if it after applying force on the body 1 kg and if it accelerated 1 meter per second square, then this applied force is called unit force. Unit force. That means unit is 1. That means you see here, if we put M equal to 1, A equal to 1 because acceleration 1 meter per second square, and F is 1, then you see here 1 equal to K, that is K equal to 1. Thus we can proceed by applying the definition of unit force, that is applying the definition of unit force, that is F equal to 1, F equal to 1 Newton, that means 1 Newton, and M equal to 1, A equal to 1, then K equal to 1. Then K equal to 1. We have, and finally, F equal to K M A. If we put like as 1, 1, 1, then K equal to 1. Now, this number is what? Equation number 1. Yeah, that's we have find F equal to KMA. It is the equation number 1. We get what? Applying the definition of unit force, we get K equal to 1. No, now putting the value of K in 1. Putting the value of K in 1, we have F equal to, if we put here K equal to 1, then what? This one is MA. F equal to what? MA. If K is 1. Thus we can prove this. That means state Newton's second law of motion and hence prove that F equal to MA. As it is proved. Now we'll do some numerical problems. No? And what are the problems we write now? Now, the first problem, numerical problem is what? A force produces an acceleration of 2.0 meter per second square, no, in a body A and 5.0 meter per second in another body B. Find the ratio of the mass of A to the mass of B. A to the mass of B. Now you see here, no, same. A force produces an acceleration. Force is same. Here, a force produces an acceleration of that within A. Suppose it is a body A. Body A. No, force applied. No, and produces what? Acceleration 2 meter per second square. Here notice that this 2 meter per second square can be written as 2 meter second minus 2. That and that same thing. This power, this denominator taken, no, as a numerator. That is the difference. Now, another force, suppose, another force means force is same, acting, it is the same. Same force, acting B, and its acceleration 5 meter per second square. As the force is same, here value of force is that one and value of force is that one. That is, force is constant, same. We can cancel force. Directly you can write as that equal to that. So we proceed like a force for the body A, for body A, value of A is how much? A is what? Acceleration. A is how much? Acceleration of 2 meters. 0.2 means what? 2 meter per second square, and mass is not given. Suppose mass, it is mass means what? Mass for A, question mark. Mass for A not given. No, it is for A, and for force for, no, force for body B. Here A, it is acceleration for A, acceleration for B equal to what? 5 meter second square, and here also mass B not given. mass B, that means mass for B, no, not given. Now that means force for body A, the force, and the for body B, it is the force. Now, for body A, when we apply force A, then these and these produce. When a force applied for B body, then that and that produce. That means F equal to it is A. F equal to what? Mass A into acceleration A, and as it is the same force, no need to write A here. When it is act on a body A, and when the same force act on a body B. That one. No? Force applied is the same one. Force applied for A, MF produce and AC produce, and force applied for B, MB produce, and what? That is what? M into B, mass into velocity, mass into acceleration, mass into acceleration. Now you see here, as the force is, bellow force is that one, and the bellow force is that one, that is that equal to that. That is M A equal to M B A B. M is mass for A, acceleration for A body, and mass for the B body and acceleration for B body. Now put the value. What factors are given? Acceleration for A body 2 meter per second square. Now two types of numerical problems. One is we can directly do this one. Other is what? Applying the dimension. Applying the dimension. Here we do this one. Applying the dimension. Dimensionally we can do do this one. You see here, we have to find the ratio of the mass A to the mass B. Here A to the mass B. Value of acceleration M is what? 2. MA not given into 2 meter per second square equal to MB not given into 5 meter per second square. It is numerically done. You know that dimensionally done. No. Now MA, you write here MA equal to, this is what? As a product. This product number comes as a denominator. 2 meter per second square. No? And this MB. Because it is the ratio of the mass A to mass B. Mass of A to the mass of B. And that is the same. This one. Now you see MA equal to, that one is 5 by 2. 5 by 2 into, this is the upper one. Upper one we write it same, meter second square, and lower one L type. Numerator comes as a denominator and denominator comes as a numerator. That one. No? Now these are cancelled. That second square cancelled. Therefore ratio of mass of body A to the mass of body B equal to 2.5. 2.5. When you feel difficult to use the dimensionality, then you can simply use this one, no need to write that the units, and finally you have to write the unit. Now the second problem. Problem number 2. A force of 0.6 Newton acting on a particle increases its velocity from 5 meter per second to 6 meter per second in 2 seconds. Find the mass of the particle. Find the mass of the particle. Now you see here a force of that Newton. The law of force is what? Force 0.6 Newton. Force 0.6 Newton. And acting on a particle, increases velocity means what? First one is the initial velocity, means u. Initial velocity u equal to 5 meter per second. And final velocity v equal to 6 meter per second, and time is what? Time t means 2 seconds. No? Then we have to find mass. We have to find what? Mass n equal to question mark. No. It is the first initial velocity. After applying the force, this initial velocity goes to increases up to what? 6 meter per second. So it is u, and it is v, and it is time t, and the other one, that is the Newton. Now we have to know what is Newton. What is Newton? Very fine point. What is Newton force? There are two types of force. Especially there are two types of force. One is what? What is Newton force, and other is what? What is dyne force. Now, if you know what is Newton and dyne, then you can easily apply it, or you can do the problems using dimensionally. Otherwise, it is not possible. So, what is Newton force and what is dyne force? Just we discuss here. You see here, when a force is applied on a body of mass 1 kg and produces 1 meter per second square acceleration, then the applied force is called what? Newton force. 1 Newton force or Newton force. Suppose it is a force, applied force, no, and this acts on a body of mass 1 kg and produces acceleration 1 meter per second square. Then this force is called what? Newton force. Newton force. It is what? Newton force. Now, So we can write here 1 Newton force. It is the 1 Newton force means what? 1 kg into 1 meter per second square. Again you see here, when a force acting on a body of 1 kg and produces 1 meter per second square acceleration, then the applied force is called the Newton force. So Newton force means 1 Newton force equal to what? 1 kg into 1 meter per second square. Ultimately we get what? Kg meter per second square. So unit of 1 Newton means what? Unit of 1 Newton means what? Kg meter per second square. Like this, what is dyne force? What is dyne force? One dyne force means when a force applied on a body of 1 gram and produces acceleration 1 centimeter per second square. Then the applied force is called what? Dyne force means what? 1 dyne force equal to what? 1 gram into 1 centimeter per second square. That means gram centimeter per second square is the unit of 1 dyne. Unit of 1 dyne. Now we solve this one applying dimensionally. Now you see, from Newton's second law, that means first one, define Newton's second law of motion and has proved that F equal to ma. No, F equal to ma. Now here we can write as you see here m F equal to what? ma. m a. F equal to m is what? V minus u by t. F cross t equal to m u or mv minus mu. mv minus mu, it is mv. It is v minus u. That is the one type of formula. Here there F1, T means here that one, M means we have to calculate it, final velocity means that one, initial velocity that one. It is the applicable formula, so we can write here. We know F means 0.6 Newton, M and V means what? 6 minus 5, V means what? 6 and U means 5 meter per second. It is T for 2 seconds. T for 2 seconds. Ultimately we have that for 4.106 Newton means we can write as what? Newton means what? Kg meter per second square. From the definition of Newton force, kg meter per second square equal to mass. It is the mass at here 1 meter per second and what? 2 seconds. It is the mass It is mass. It is the meter. It is the mass. It is meter. Mass. Mass into that one. Now that means what? Separate you write here the kg means upper one, meter means upper one, second is lower one. No, 6 kg dot, it is the meter, and here is what? 10 second square equal to, here is also you see here mass, it is the meter, no, and it is what? Second, this one is lower one, this second is lower one, 2 second square 2 second square, mass into meter and 2 second square. Next line you cross multiplication, 6, we have to find the mass, no? We have to mark this one, 10 into mass dot meter and second square, it is meter second square equal to, it is the cross, and that one 6 into 2 kg meter second square. Therefore mass equal to 6 into 2 means 12. 6 into 2 means what? 12 kg meter second square. Here is 10. Mass is here. This will become the denominator. So 10 meter second square. Second square cancel. Mass cancel. Therefore mass of the particle equal to 12 by 10 kg means 1.2 kg. Means what? 1.2 kg. Thus, using dimension, we can solve the problems like this. Thank you.